Okay, welcome to the Unit 2 review. We're going to take a look at this. Before we get started, just briefly talk about how we use this video to help prepare for the Unit 2 test. You're going to take out your book. You've been given an assignment, page 95, numbers 1 through 4, 7 through 10, and 13 through 21. We're going to work out some of those problems here, hopefully give you some examples to go by so that you can complete the rest of the problem. So you're going to locate those problems. I'll tell you which ones we're working out. Follow along as we discuss them in the video and use those examples to answer the other questions in the assignment that are going to be similar to those. So for example, we'll see a question on a histogram. You can carry that over to the next question you see on a histogram. Before the test, you might even want to watch the video again, go back through these examples, make sure you remind yourself of all the little nuances of every type of problem that we've done, and make sure you're asking questions in class about problems that are giving you trouble as we go through this. I'll be around circulating as you're watching this video, of course, and feel free to call on me for help. That said, let's go ahead and jump in. The first problem we're going to look at is taken from number 7 on the page 95 assignment, and we've been given a list of percentages of persons completing 4 years of college in each of the 50 states. So basically in every state they've got a percentage of persons completing 4 years of college, and they recorded that for each of the 50 states. Now the first task that we've been given with this data set is to organize the data in a frequency distribution. Now when we do a frequency distribution, that basically just means we're going to organize groups of classes representing each set of numbers, and we're going to find the frequency for each of those by counting the number of occurrences in each of the classes that we have. So we'll start off by first off identifying our classes that we have. The first thing that we need to understand is that we're going to use 5 classes in this study. So we'll be doing that here, and when we identify our 5 classes, the first thing we're going to have to do is find the class width. So what we'll do is we'll find the range of values, and just a reminder, range is the highest and lowest terms, the distance between those two. And as we look through this list, I've kind of already scouted it out for us. The lowest value is 15, and our highest value is 38. So we're going to subtract 38 and 15. So we get a range of 23. Now to find the class width, we're going to take the range and divide it by the number of classes. And we can see here that we're going to have 5 classes. So we'll take that 23 and we will divide by 5. And of course that's going to be 4.6. And if you remember the rule, we're always going to round up to the next whole number. Even if it works out to be a whole number, we're still going to go up to the next whole number from there. So the class width here is 5. And that is important information to know as we set up these classes. So in setting up the classes, we'll just continue with that information, and we'll go starting with the lowest value, and the lowest value again was 15. 15, and if we count 5 numbers we want to include in this class, 15 being the first, 15, 16, 17, 18, and 19 would include 5 numbers. So the class includes the values 15 to 19. The next class would start where that leaves off, which would be at 20. And it's going to include values of 20 to 24. The next class would include the values 25 to 29. And then the next class would include the values 30 to 34. And then our last class will include the values of 35 through 39. Now you always want to make sure that it doesn't necessarily have to end on the highest number, but you want to make sure that your highest number is included in that last set, and you haven't either gone beyond that or haven't included enough. So you want to make sure that the last or the highest number will be included in this last set, and it was 38, so we know that that would be in that last set, so we're good to go there. The next thing to do at that point is to start tallying up how many items come in each class. So as we go down this first column of numbers here, I'm going to try and see if I can fit it all on the screen. The first value, 23, would be in this class right here, so we'll put a mark there to tally it up. Going down the list, 26 would be in this class, 30 would be in this class here, 34 would be in the same class, and 26 would be up here. And then we just continue to go down the list. There's 50 items here, so I'm just going to spare the time and skip ahead, and I'll come back with you in just a second. Alrighty, so you can see I'm back, and I've tallied up all of the states. We can see that our first group contains 3 values, so we'll say the frequency for that group is 3. Our next group, 20 to 24, contains 18 values, so that's our frequency for that group. The third group, 25 to 29, also has a frequency of 18. 30 to 34 has a frequency of 8. And our last group, 35 to 39, has a frequency of 3. Now, that is how we make a frequency distribution. Don't necessarily have to include the tally column there. However, I think that it kind of helps demonstrate the point that we've counted them all out, and you can kind of see what's going on there. But basically, all we're going to do is define our classes and list a frequency for each of these. Now, if you continue on into the assignment, the next problem, I believe problem number 8, asks you to do a few things with this. The first of those is to make a histogram. So what we're going to do is we're going to go ahead and take the frequency distribution that we already had, and we're going to add a few things to it. Give me 1 second here and I'll fill in what we already had. Okay, so you can see I've basically just taken the frequency distribution that we had back on this slide, and I've transferred that information over to this slide, looking at the classes and the boundaries, or excuse me, the classes and the frequencies. If we're going to make a histogram, which is our first task here, we are going to need the boundaries for our classes, and we are going to need the frequencies. So we'll go ahead and fill those parts in on this chart so that we can go ahead and get all of our data together. Boundaries, remember, we're just expanding each class by half of a number on each side in order to make the classes meet together. So if we take this 15 and bump it down, we would bump it to 14.5, and we'll bump 19 up to 19.5, so that when I do the same thing with this class, the 19.5 in this will actually touch up against the 19.5 from the first class, and our histogram bars will actually touch. So this boundary here would be 19.5 to 24.5. The next one will be 24.5 to 29.5. The next one would be 29.5 to 34.5. And the last one would be 34.5 to 39.5. These are the boundaries that we've defined for our frequency distribution, and we will now set these up into a histogram. Okay, and you can see now that I've taken that information and I have gone and put the boundaries that we got from the data up there into our x-axis. That's these values right here. I've just placed those along the x-axis at equal increments, and the frequencies are going to be graphed on the vertical axis, so I've kind of put those numbers over there, put a scale so that I can chart those, and that is what we're going to put in here. So our first bar goes from 14.5 to 19.5, and there is a frequency in that group of 3, so we will raise our bar up 3 units from there. That's going to put it about right there maybe. And again, you've seen me do these. I'm not always right spot mark on, but that's pretty close to 3. The next group goes from 19.5 to 24.5, And there is a frequency in that group of 18. So that is going to go all the way up to 18. And we'll put that bar in. And if you have any other issues on histograms, you can remember we made another video about this earlier. Just continuing along though, I'll finish this one out. This goes to 18 as well. And the next group goes from 29.5 to 34.5, and it's going to include 8 values. So it'll have a height of 8, which is going to be about right there. And our last group goes from 34.5 to 39.5, and it has a frequency of 3. So this is a fairly symmetric distribution. You can see a pretty nice balanced shape, maybe a little skewness to the right, but it's fairly symmetric, or close enough to consider it symmetric. But this is our histogram. Notice I've also, and a few of you have had some issues, I've labeled my x-axis based on what we're looking at. These values along the horizontal axis represent the percent for each state, or what stands for the percent. Up the top, I've given it a title that we can see up here. That's an important aspect that we want to make sure we remember, and our vertical axis is labeled as the frequency, because that's the frequency or the number of states that fall into each of those categories. And you can list it however you want in that aspect. But we want to make sure we define what this bottom axis is defining, and here it is talking about the percent completing a 4-year college. Okay, so that's the first part of number 8. The second part of number 8 asks us to make a frequency polygon. Now, when we make a frequency polygon, we're going to need a little bit more information from up here. So, real quickly, for the frequency polygon, that's a long word to write. For the frequency polygon, I'm going to need the midpoint of each class, and I'm going to need the frequency. Okay, so again, it's very important that we just identify what values we're going to need with each type of different graph that we do. We're still talking about the same information, we're just going to use different values. So we need to come up with the midpoint of each class. Remember, we find the midpoint by adding the two values, 15 and 19, dividing that by 2. And the midpoint in that case, 15 plus 19 is 34. 34 divided by 2 is 17. We'd find the midpoint between 20 and 24, that's 22. Midpoint between 25 and 29 is 27. Midpoint between 30 and 34 is 32. And the midpoint between 35 and 39 is 37. Notice that each one of these values is 5 units apart. Not coincidentally, our class width is 5, so that kind of just works hand in hand with that. So, as we go to do the frequency polygon, I'm going to kind of try and fit that over here. We're going to use those midpoints, and I kind of left those out. Notice we'll leave this first one blank, and we'll talk about that in a second, but my midpoints are going to be 17, 22, 27, 32, and 37. Okay. Notice that the labeling for the axis is still the same because our graph is still showing the same information. Our frequencies are going to be plotted. We have the midpoint of each class now instead of a range of values that we had for the classes before. So we're just going to use that information. At 17, we were talking about our first class, that was the midpoint. We had a frequency there of 3, so that's going to be about at this height right here. For the next class, having a midpoint of 22, our frequency was 18. So we'll go all the way up to 18 and put a point there. Hopefully that's pretty close to being on line. Going up to the next class was a midpoint of 27. It also had a frequency of 18. And the midpoint of 32 was in our 4th class, and it had a frequency of 8. And then we finish out with a midpoint of 37 having a frequency of 3. Let's see, I hope that's high enough. It looks pretty good from here. Again, it's kind of hard to get the angle, but we're now going to just connect those dots. And we want get a shape of the distribution. Remembering on one other aspect, we want to close off the figure. And we do that by connecting to a last point on each end, like this. And I'm just doing it in a different color to show you that it's an extra part. We must add those pieces on. If we were to continue the scale down here to this point would have a value of 12, and that's keeping with the pattern of an increase of 5 on every one, and this last one would have a value of 42. And that gives us a completed frequency polygon. Showing the same information that our previous graph did. If we look at this graph here, it's showing us the same thing. It's just this one uses bars, and this one is using points connected by line segments to get the same shape. Because we're using single points though, we just identify the midpoint of each class and work with that. Okay, and that's the second part of problem number 8. Finishing out problem number 8, we were asked to do the ogive of the information. Now when we do an ogive, you may remember, we're looking for different information again. And let me make note of that real quickly. Our ogive will always use cumulative frequencies. Well, I guess the first thing it's going to use on the horizontal axis would be the boundaries, which we already have. Same ones we used in the histogram over here. But we're also, instead of using frequencies, we're going to use cumulative frequencies. I'm running out of space, but there you go. Cumulative frequency is the total of all the frequencies up to that point. So it's very important you pay attention to what this means, because if you understand what's going on here, it really makes making the ogive simple. I know there's been some confusion with some of you in the past on that topic. Cumulative frequency means what we have in total up to that point. So if we start with this first class at 14.5, we don't have any values that are there, but by the time I get from 14.5 to 19.5 through this whole section, I have encountered a frequency of 3. And then from there, I would go up to 24.5, and by the time I get to 24.5, I've encountered these 3 and another 18 more. So we have a cumulative frequency of 21. By the time I get through the entire third class, I would be at 29.5, and I would have encountered an additional 18 values. So that's going to put me at a total of 18 plus 18 plus 3, giving me 39 as my cumulative frequency by the end of the third class. By the end of the fourth class, we've reached the boundary of 34.5, and we have a cumulative frequency, which includes another 8 items. So that would be 47 as the cumulative frequency. And by the time we reach the end of our last class, we're at 39.5, and we have included a frequency of 50 values. Now, if you think back to what we were originally looking at, we were looking at a percentage for each of the 50 states, so we should have 50 items as our cumulative frequency. And there you go. Now, all we're going to do, once we try to set up our ogive, we're going to use the boundary values, and we are going to use the cumulative frequency values, and we're just going to make a graph with those. Okay, so here we go with our graph, and we are looking at the the graph that I've got started up for the ogive. And remember, once again, we have the boundaries here on the bottom or across our horizontal axis. So we're using those values here, and on our vertical axis we are using the cumulative frequencies. So as we go and try and put all those together, let me erase that circle so I have room. I'm going to fill in the cumulative frequencies. Now remember, once again, our cumulative frequencies go all the way up to a value of 50. So we have to include that on our graph. And I've got, I believe, 10 spaces here, so I'll try and go by 5s here, I guess would be the wisest thing to do. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And all we're going to do now is put a point at each of the cumulative frequencies for the boundaries that we encounter. Remember, again, that our lowest value was 15. So when I am at the value of 14.5, which is my first boundary, the number of items that I have encountered in that list is 0. I do not have anything that is 14.5 or lower. So we are at 0 when we start out. That is at the first boundary point. And that seems to be a trend that we tend to forget starting at that first point. The first point will always be 0. Now, if we look back, by the end of our second class, or excuse me, by the end of our first class, we are at 19.5, which is our next boundary point. And that is when we have a cumulative frequency of 3. We have gone from 14.5 to 19.5, and we have encountered 3 different values. So we will be at 19.5, we'll be at 3. And that looks like it might be a touch high. Let's see if I can lower it just a little bit. Maybe that's about it. And we'll go from there. At 24.5 is our next boundary point. Our cumulative frequency by that point was, I believe, 21. So we'll go up here to 21 and put a point in there above 24.5. Okay, and at the boundary point of 29.5, we added another 18 in, so we're now at a cumulative frequency of 39. That's going to be up here just below the 40 mark. After that, we had a cumulative frequency at 34.5, which is the end of the next class, and that had a cumulative frequency of 47. So we'll be up here getting very close to the top. And at 39.5, which was the end of our last class, we were up at 50, which is the top point of the graph. Okay. Notice again that the ogive always climbs upward. Okay. It's never going to be going downward at any point. So we'll finish this out by connecting those points. And what the ogive does more than anything is show you where you had the most growth or the most occurrences of something. So again, it's always going to be pointing up at the end. Okay, it's always got its highest point. Always highest at the end. Okay, when you're doing an ogive, it always goes up. It never goes down. Notice again, though, I do have the same things we've put on all of them. I've got a title. Now my vertical axis is the cumulative frequency, not the frequencies. And my x-axis, or my horizontal axis, is still representing the percents completing a 4-year college. Same information, just presented differently. Again, you want to make sure that you're paying close attention to what you use in each of the graphs. The histogram will always include the boundaries and the frequencies. The frequency polygon will always include the midpoints of each class and the frequencies. And then, of course, the ogive will always include the boundaries of each class with the cumulative frequencies. Okay, if you remember that and you know what each of those things is, you should be able to complete any of those graphs. Okay, let's continue our review by looking at one more type of problem. This is actually taken from number 18 from your assignment on page 95. This one is another issue that we've had some issues with in class that we want to take another look at here. Construct a pie graph to analyze the spending by the average college freshman purchasing items for school. Okay, we're making a pie graph here, a little bit different, different concept. We're trying to put everything into a circular representation based on the percentages in each category. So what we have to do first is find the percent that each category is using of the data, in the data. So what we have to do is get a total of all the things spent. So in this case, we're going to total up all of the money that was spent by college freshmen. And if we take a moment and look at this, we have a total of $12.85 here. And to find the percentages in each category, you're going to take each one of these and divide by 1285. So we would take that 728 divided by 1285, and that's going to give us what we would estimate to 0.567. I'm just going to carry out 3 decimal places for rounding purposes. The dorm room items was $344. We divide that by 1285, and that's going to give us a percentage of what we would round to 268 or 0.268. For clothing, $141 divided by 1285 is going to give us what rounds off to be, it's 1.110. It was 0.109 something, and we round up to 10, so we get 0.110. And for shoes, 72 divided by 1285 is going to be 0.056. Now, a lot of money spent on shoes in relation to all of the other items. Now, we're going to get degrees by finding the percent. The degrees are equal to percent times 360. Basically finding that percentage of the 360 degrees in the circle that are going to be occupied by that section. So if we take 0.567 and multiply it times 360, we find that this section is about 204 degrees. We'll round it to the nearest whole degree. 0.268 for dorm room items, multiplied by 360 is going to give us about 96 degrees. 0.110 is the percentage of clothing, multiplied by 360 is going to round off to be 40 degrees. And then shoes with 0.056 times 360 is going to give us approximately 20 degrees. So now that we've found that, which is the hard part of setting up the pie chart, we want to make sure that we understand how to get these numbers. We're just going to kind of sketch the rest from there based on these numbers. Now we see the first one, electronics and computers, is going to take about 204 degrees. Now 204 degrees is a rather large angle. So we would want to, let's see, here's my center. If I was to come horizontally from there, straight across would be 180 degrees. We're going to go a little bit more than that. So we'll say this is about 204 degrees. We will say that is computers and electronics. The percentage there was pretty high. That was 0.567, or over half. So we'll say that's 56.7%. We'll label that in there, maybe just for the viewer to kind of get a feel for what percentage that actually is. Our next category was dorm room items, and that was 96 degrees. Let's say we're looking at this horizontal line coming off again. If I was going to come straight down from this center point right here, that would be 90 degrees. We're going to go a little bit past that, so see if I can get something close to 96 degrees. So this was dorm items. And again, that percentage was what? 0.268, so that's 26.8% for that category. I guess there was more than one. And then our last two categories were clothing, which was 40 degrees, making up about 11% there. 40 degrees would be, let's say, if we're going to go this direction, it'd be probably there. I might be a little off with that. Let's see if I can get that a little bit better. I erased some other things, but that's probably going to be about right there. Let me fill in these other lines to make things better and clean it up a little bit. Okay, so this was clothing, and that was 11%. And our last category was shoes, which would be in this category here. and that was only 5.6%. So we'll label that. And basically you can see, while this is not perfect, I've kind of estimated these things, but I've based it off of my angle measures that I got up in this first part here. So we have a good feel for what these things should be. Just kind of knowing what obtuse and acute angles kind of look like. Okay, so that's the end of our video review. Hopefully you've gotten some examples of some things that you're going to encounter on the rest of the review. Make sure you're practicing for the test by doing the remaining problems in the assignment. Again, if you've got some questions about some things, make sure you're speaking up, either asking me or one of your classmates on how to get these things. We don't want to go into the test without knowing how to do something. So hopefully you've gotten some from the examples we've done and you got enough to go by. But again, if you got some more problems or no more questions, please make sure you ask them. And good luck on the test tomorrow.